This is an example of a typical rack crate that we find coming from some of our competitors or maybe other countries. It's a standard design. It has a handle on the cap. The cap is removable. Here you see those lag bolts or lag screws that I was talking about earlier. Sometimes they use a link lock like these fasteners to hold the cap down. By the way, just note that we've discovered because the crate is so square and stiff and holds together, we only need 2 link locks per side to hold everything in and hold all of the weight and prevent any kind of bowing. Typically, many of our competitors would have 3 or 4 link locks, so that's an additional cost savings and additional speed to load and unload. Anyway, so this particular crate may be secure, have the cap secured with lag screws or with link locks. And in order to load the ramp, with the ramp, which I don't have here, or a forklift or whatever, the cap has to be removed, the rack has to be put in, and then brackets, steel brackets usually, that bolt onto the front and rear of the rack are then bolted into the frame or the base of the crate to hold it to the base. So this is an example. This would be 4 different brackets that go in the corners and hold the rack down. Sometimes the rack has flanges that can be bolted directly. Sometimes there's an L bracket that's a little longer that has more bolts that would bolt to the rack and then also bolt to the base. But it requires tools, takes time. Again, this takes 6 times longer to load and unload than our toolless rack crate. In addition, the industry standard is to use a polyethylene foam. It's generally white foam. Lighter weight racks would use a 2-pound foam. That tends to creep under heavier weight, gets dirty, doesn't look nice, it tears easily, versus the higher performance beaded foam that we use. As the rack weight goes up, most industry people will design, and the cushion curves would show that you need to use 4-pound or 6-pound foam, which gets very expensive, especially compared to the alternative that we use. So for heavier weight rack crates, the higher performance foam, the beaded foam, is actually cheaper and easier to use and machines better and glues better than this polyethylene foam, which has larger air bubbles and ultimately compresses. So that's just a little side note. But more grave, I would say, is that many folks use this black 1.7 pound, really it's 1.5 pound recycled polyethylene foam as these bumpers to hold their racks in. And honestly, we've done that in the past, and it's something that looks nice on a new crate. The rack goes in, it looks like it's holding it. It's a very inexpensive solution, and what we've found in testing is it just doesn't work. So one of the tests required on these rack crates is to do a side impact test. And what happens in a side impact test, the base of the rack is secured, or the base of the rack is secured to the base of the crate, hits a side impact, it cantilevers, and this foam, you can see just even with my fingers, compresses very easily. And with hundreds of pounds or 1,500 pounds, it compresses to nothing. And what we've seen in testing of this type of rack crate, the top of the crate actually blows out, breaks the crate, and essentially this doesn't do anything. So that's why we've moved to the beaded foam for precision, and we know that it works because it's passed the testing.